Hello, my name is Lee Burrows, and I'm an ecology PhD candidate at UC Davis in the Department of Wildlife, Fish, and Conservation Biology. I completed my undergraduate degree here at UC Davis in the Wildlife Department, where I worked in fisheries research labs and with government agencies and developed an interest in applied conservation in California systems. Today, my research focuses on how we conserve snakes in highly altered and human-dominated landscapes. Much of my work takes place in California's Central Valley. Historically dominated by seasonal wetlands and floodplains, over 90% of this habitat has been lost to human development. Today, the landscape exists as a mosaic of agricultural fields, canals, managed wetlands, and urbanization, where water and habitat are tightly controlled. Despite these changes, snakes still persist here. The giant garter snake is a state and federally threatened species endemic to the Central Valley. The giant garter snake has been extirpated from 2/3 of their historic range and now relies heavily on rice agriculture as surrogate wetland habitat. At the same time, invasive water snakes pose a potential threat as both novel predators of native aquatic species and novel competitors occupying similar ecological niches to the giant garter snake. My research asks, how do management actions, landscape context, and environmental variability shape snake populations? And how can this inform conservation in human-dominated landscapes? I approach this through 3 areas: invasive species management, landscape and habitat context, and agriculture and water management. In my first chapter, I evaluate long-term removal efforts and show that intensive trapping successfully eliminated one introduced water snake population, an extremely uncommon and unique outcome in snake management. This work also highlights how environmental stressors like drought can create windows of opportunity that improve eradication success. Much of the remaining habitat for native snakes exists within agricultural systems. Using spatial data, I map habitat and identify priority areas for conservation, showing how land use and water availability shape where snakes can persist on the landscape. For giant garter snakes, rice fields function as surrogate wetlands, but mismatches between rice field flood-up and snake activity may create seasonal gaps in habitat and prey availability, creating a survival bottleneck for giant garter snakes during their spring emergence. This presents an opportunity to work with farmers and water managers to better align agricultural practices with snake ecology without sacrificing productivity. Snakes sit at the intersection of ecology, agriculture, and water management. Conserving them requires understanding not just their biology, but how human decisions shape the landscapes they depend on. My research aims to strengthen the scientific foundation for conservation strategies in these shared landscapes, where the futures of wildlife and people are inherently linked. Thank you.